quality of service used to be its own CCNP certification exam. Like there was an entire series of videos dedicated to that one topic. And I'm going to try and cram that all in to this one video. Ready? In a way, I'm kind of joking, and in a way, I'm kind of not. Truth be told, what's happened to that quality of service series is it's bled into all the other exams. It's not that quality of service is gone. It's just that every exam has quality of service now because it's such a critical thing to have in every single network environment. So what we're going to do here is examine a high-level view of the quality of service tools that you can use every hop along the way. And by the way, that's called a per hop behavior, or PHB. See, here's the idea. Not all network traffic is created equal. They haven't had their Declaration of Independence yet. So there's different types of traffic that we need to treat differently. For example, we have this IP phone that's just super sensitive to delay. It's super sensitive to loss. If any kind of packet loss happens, there's going to be an immediate notice by the user of a gap in the conversation. Whereas all these other ones, let's say this guy's doing a backup across this wide area network. These guys are just surfing the net. I mean, they're sensitive, I guess you could say, to loss, but I mean, nobody's going to notice if your web page loads like this, whoop, or loads and then loads, right? But if you're on a phone call and suddenly the conversation stops for a second, you immediately notice that. It's terrible. It breaks up the whole conversation. So what I want to show you is the tools that you have at your disposal. And it's not going to be like cramming the entire CCNP series into this one video. It's going to be a high-level view because what I want to do is plant those seeds that when you're getting to the point where you're going to roll out quality of service, you're going to remember it, be like, oh yeah, I can do that. And then you'll know exactly what to search for and exactly the direction to go in your configuration. You ready? So first and foremost, quality of service is traffic discrimination. It's a way of saying this traffic is more important than, say, this traffic or this traffic. And there's all kinds of different levels of quality that you can have on your network. The big thing to understand is the tools that you literally have in your tool belt. There's about 6 of them. The first thing that you need to do when traffic's coming through on your network is be able to discern what type of traffic it is. And that is known as classification, or classifying the traffic. See, we have one network card with just streams and streams of data coming in. And when we turn on quality of service features, one of the ways that we do it is through a configuration command known as a class map. And in that class map, we have about, I'd say 10 to 12 different ways of identifying traffic that comes in. You could identify it by what interface it came in. It came in on fast Ethernet 0/0.10, VLAN 10. That's our voice VLAN. That immediately gets priority, right? We could do something like that. Or you could say, let me use an access list. That's web traffic. Or you can use, there's application layer inspection. Why is it slipping my mind? NBAR, network-based application recognition. That's a feature that allows the router to actually rip open the packet and look down to the application layer. Because sometimes there's applications that share port numbers. Like you might have instant messengers using the same port number as normal web traffic because people who created the instant messenger know that port is often allowed through firewalls. So they'll use that. And we don't want to misclassify it, so you can use NBAR to look. I mean, there's all kinds of different ways to classify. Some of them light, like, it came in that interface. Some of them intense, like network, like it's going to slow your traffic down, right? And because of that, we'll often go to the next step. It's not mandatory, but most of the time you will, of marking. And it's the same concept of shipping a box, right? Let's just say we're shipping a box to, an apple orchard, which has a whole bunch of apples. Maybe, how about from an apple? We're an apple orchard, and we're going to ship this box, full of apples inside of it to one of our customers. Well, what are you going to put on that box? A label, right? That says where it's going. We don't want to put it inside of the box where every single postal stop along the way, somebody's going to have to rip the box open and be like, they're apple. Okay, they're going right here. I get what these are, right? So what marking does, there's actually 2 ways of doing it. The first is at layer 2 of the OSI model. It's known as the class of service marking. It's a way that you can go into the header, the layer 2 header, think when you're thinking layer 2, I want you to think data link layer, I want you to think MAC addresses, I want you to think like this is switch infrastructure, right? That's the primary place class of services used is within the switches because they can prioritize traffic. And you can put a marking. It's just a number from 0 to 7, which says the relative level of priority that frame, because we're talking layer 2, should have. Now, it's designed to be exactly like you and I think it is. The higher your marking, the higher your priority. But it's totally up to you and me of what we want those markings to be. They're just markings. Now, if we want to follow the guidance of all the best practices, then it's best to say, okay, higher is better, but we don't have to. That's up to us. But keep in mind, class of service, because it's at layer 2, what happens as soon as it hits a router? Same thing that happens to every layer 2 header. It gets ripped off and replaced. So that's why we also have a marking at layer 3 of the OSI model. That's known as the type of service field. And the great news about the type of service is it can survive all the way from the start to the end of your network communication, and the routers can react to it along the way. So class of service is great in the switch network, but once you get it to the router will often convert the class of service marking over to a type of service. Now, how many levels of marking do you have at the type of service? That's a whole discussion, because the primary marking method, there's actually multiple marking methods, but the primary marking method is actually one known as DSCP. That stands for Differentiated Services Code Point. Don't need to know what it stands for, but if this were the CCNP series, I would probably spend an hour, literally an hour, talking about all the different markings that you can have, why they are that way, the different drop preferences on each. I mean, there's just a whole discussion around that. So just imagine with DSCP, we have a box of 64 crayons, right? And we can color the packets with different colors of crayons, and it's up to us what we do with those colors when they're received, because that opens the door to the conversation of queuing. And let me wrong button. Let me go down here and talk about queuing, because every router queues. It's built into them. If you have hang on, whoa, hang on. Come back, hang on. I'm going to make a statement. Brace yourself. This is a big statement, and I want you to remember it forever. Write it down. If there is no congestion, there is no need for quality of service, because quality of service works only when there's congestion. Does that make sense? So what I'm talking about is when you've got a router, oftentimes there will be a speed mismatch. You'll have, let's just say, a T1 speed, which is 1.544 megabit per second. That'd be a slow link, right? And then we've got our 1 gigabit per second over here. That's 1,000 megabits per second. And all this traffic's coming in, and it's like, I can't get it all out. It's too slow. So what's the router do? Well, in its memory buffers, it establishes a queue. This is its default behavior. All routers that claim to be a router will queue. And the default queuing strategy that they use is one that you've probably heard before, FIFO. First in, first out, right? Whatever's received first is the first one to exit the interface. And that sounds fair until you're like, oh no, our little voice over IP phones, they're sending packets, and unfortunately they happen to be, just because they arrived a little later, at the very end of this very long line of packets that have, internet surfing, backups, and all this stuff in front of it. So we might want to convert to a different kind of queuing known as priority queuing. And priority queuing says, I can take those packets while they're in the queue. And I'm going to emphasize it again. While they're in the queue. Hang on, back to my monumental statement. Because if there is no congestion, there is no queuing. And if there is no queuing, there is no quality of service, right? It just goes right through the router, just like water out of a faucet. And that's fine. That's what we want. But when there is congestion, it does queue up, and priority queuing moves whatever traffic we want, which in this case would be our blue voice over IP packets, which are classified and marked, all the way to the front of the line. So while everybody's waiting, it's like that guy in the lunch line. You're like, hey, come on, I've been waiting here the whole time. Well, that's what happens all the time to all this traffic. That's all, hey, and then the voice over IP traffic goes right out the front of the line. But Cisco saw a problem with that. They said, oh, whoa, that could lead to traffic starvation. So they actually created, and I'm going to fast forward because I could talk about queuing again for hours and hours. There's so much fun stuff there. But let me fast forward to the one that Cisco created. This was their baby. It's called low latency queuing, which is actually a combination of 3 different queuing mechanisms in one. It's typically called PQ, CB, WFQ. What? Priority queue is what that stands for. Is low latency queuing allows you to have a priority queue up to a limit. So it'll say, okay, you designate the priority. Okay, voice over. Yeah, I want voice over IP to be my priority traffic. Okay, that's fine. It'll be prioritized, but tell me your cap. 1 megabit per second. Oh, okay, great. Voice over IP will get the priority, but it will be capped at 1 megabit per second because you don't want unlimited priority, right? Because otherwise you could starve out all the other traffic trying to cross that T1 line because you have too many phone calls, right? Nothing else gets bandwidth because it's all getting the priority. So it's priority, but it's cut off. It's actually technically, we'll see this one later, policed. But what about all the other traffic? Well, the other traffic gets a guarantee. That's the class base. So you can guarantee, if we've got, a T1 line, we've got 1544 kilobits per second, right? That's converting megabits to kilobits, right? You got a quote unquote a lot of bandwidth that you can hand out there. Priority queue says you will be guaranteed bandwidth and you get the first bandwidth. Whereas the class-based queuing is like, oh, you just get your bandwidth guarantee. So voice over IP may get to the front of the line, but don't worry. It's like, I don't know, the lunch line. You'll get your meatloaf. Don't worry. The meatloaf is still going, there's going to be enough meatloaf for you, right? And that's what happens with this 1540. You're getting the guarantee. That's the class-based. It's just not going to be the first. You might get some old meatloaf, right? It's just not going to be the first bandwidth. But what about this last queuing mechanism? Weighted fair queuing. That's for all the traffic that you don't specify. So you might say, okay, voice, video, you all go in the priority queue as an example. You actually wouldn't normally do that because video can pummel the voice. But okay, voice, you go in the priority queue. Video, you get your guarantee. You're a class of traffic. You'll get your 500 kilobits per second. Don't worry about it. There's enough meatloaf for you. Video, right? Everything else that I didn't just specify there, you get treated with weighted fair queuing. And that simply means low bandwidth senders have priority over high bandwidth senders. So the telnet session that's just doing one character at a time here and there would get priority over the YouTube stream sitting in the queue, right? That's where the name comes from. It's just fair. I mean, he didn't send that much traffic. He should get a little priority over the people that are sending traffic all the time. So Cisco took those, combined them all into one queuing mechanism that they call low latency queuing. When you get deep into quality of service, you'll find your queuing strategy is a big one. Oh, and this next one is so fun. Weighted random early detection is technically known as a method of congestion avoidance. Listen to the name: weighted random early detection. Here's what it does. It plays on the properties of TCP window sizes. See, this guy's sending a backup, right? And if you guys know about TCP windowing, it pretty much says, here's how many packets I send per acknowledgement that I get back. And these guys are really aggressive. They're like, okay, as soon as I detect that there's bandwidth there, I'm going to gobble it all up. I'm going to increase my window size as much as I can to be efficient. I mean, that's how TCP is. I want to send as much as I possibly can before I get an acknowledgement back. Well, as the router detects that there's going to be congestion, it calls the weighted random early detection sniper out to the wire. And he goes, okay, there's a category of traffic that I want you to pick off. And it's that group over there. And it's going to be the TCP based bandwidth hogs, right? The web surfing, the backup mechanisms. I mean, the stuff that can consume all your bandwidth really quickly. And it'll be like, oh, there's a queue building up. Shoot it. And what happens to the queues that are shot? Shoot. They shrink back down, right? Okay, shing, shing, shing. So the goal is to keep the traffic from queuing up to the point where you end up getting a horrible thing called tail drop. And that's where the queues are all full and it can't fit anymore. So it just drops no matter what comes in. There's no priority anymore because you've filled up everything. All the memories on the router is full, right? So weighted random early detection, you get it? Congestion avoidance is there to I don't know if you've ever played one of those video games where there's all the things running at you and there's some that are fast and you're like, shoot those little guys first, and then we'll pick off the ones that are a little slower because you want right. That's the whole goal of the game. So that's the idea behind weighted random early detection, is to stop those TCP windows from building up too big. Now, last two. We'll with the first one first because it's a lot more fun. Policing. Policing is putting anti-quality of service on some traffic. There is some traffic you just don't want. Fun story. I had a friend, actually, he's the best man at my wedding. He was the network administrator at a university in northern Arizona that shall remain nameless. Although I think there's only one university up there. Big university. And he actually completely cut off. He blocked all peer-to-peer file sharing. Guess what happened? Lawsuit. The students sued him. Freedom of speech, government funded, and they won. And he's like, are you kidding me? If I open this up, they're going to kill our internet connection with all this, BitTorrent and everything else. So what he did was he used policing he classified, he marked that traffic, and then he policed it down to 1 megabit per second for the entire campus, to where people could say, well, we're giving access, but when you divide that 1 megabit per second among, thousands of students, it didn't work out so well, but the access was there. So that's the kind of thing that you can do with policing, is literally throttle things down and cut off the traffic, or limit. How about that? Limit the traffic that you don't want. Whereas shaping is the kinder, gentler policing, right? Policing is used to keep the traffic under control that you don't want. Whereas the shaping is kind of like, well, I want this traffic, meaning once it hits its bandwidth limit, I'm going to queue it. I'm going to try and get it there. I mean, if the queues fill up, the queues fill up. There's nothing we can do there, but I'm at least going to give it a good college effort try, right? College effort, get it? So shaping is good, like that backup and restore, this guy. It would be a good idea for shaping, whereas just, normal web surfing, we'll say, might be a good example of policing. That is the entire CCNP course in 15, 16 minutes right there, right? So obviously a ton of detail can go into each one of those, but you've got it. You now know these are the tools that I can use to deploy QoS on any one of my Cisco devices. You've now seen a high-level view of quality of service tools you can use every hop along the way. That's per hop behavior. I hope this has been informative for you, and I'd like to thank you for viewing.